Trial
Welcome
version.
to the third lecture of Module 3 of Mechatronics
Trial version.
17ME754. I am Dr. B. Krishna Prabhu, Professor
Trial
of
version.
Department of Mechanical Engineering, Canara Engineering College.
Trial version.
In this session, we will see the block diagram of PLC.
Trial version.
The block diagram is already explained in a previous lecture.
Trial
But we will
version.
start with the block diagram of PLC for this particular lecture.
Trial
And we will,
version.
then see the central processing unit of the programmable logic
Trial
circuits.
version.
Then input-output interfaces. Now what are
Trial
input
version.
channels and how they are useful in PLCs. We also see something on
Trial version.
output unit that could be connected to a programmable logic circuit. Then also
Trial
we will
version.
see and end this lecture with the description on opto-couplers.
Trial version.
Here we have the block diagram
Trial
of
version.
the PLC, which shows us the internal
Trial
structure
version.
or different components that are used in any programmable logical controllers.
Trial version.
So basically, there are three very important parts that
Trial version.
any PLC includes. The first one and most important one is the central processing
Trial version.
unit. The central processing unit, you can see it
Trial
over
version.
here. So here is the central processing unit. Then we also
Trial version.
need to have the memory. So there are wide varieties of memories used in
Trial version.
any programmable logic controllers. That could be temporary memories, that could also be
Trial
permanent
version.
memories. Some of them are connected to the system operation, some of them are connected to the data
Trial
operation,
version.
so on and so forth. So varieties of memory units
Trial
are
version.
connected to any PLCs. So some of them that you can see are this is
Trial
the
version.
RAM, which is used for user programming. Then there are system ROM, also data RAM.
Trial
So
version.
different types of memory devices are useful in this one. And the third
Trial
one is
version.
input-output interfaces. So there are a wide number of buses that
Trial
are
version.
used, which will help us in interfacing with input and output devices with the central
Trial
processing
version.
unit. So a quite good number of interfaces we could see over here. That
Trial
includes
version.
a opto-coupler as well.
Trial version.
First of all, let us see the central processing unit or a CPU, which is
Trial
used
version.
in any PLC. The basic CPUs are often called as heart of the system
Trial version.
because it is the CPU that controls and does all the processing job
Trial version.
on the inputs. So the CPU controls and processes all the operations
Trial
within
version.
any given PLC. So in the PLCs,
Trial
the
version.
CPU is supplied with a clock, and about the clock we have talked something in microprocessors as
Trial
well.
version.
Whatever the job that a CPU has to do, it is always scheduled with respect to
Trial version.
any the internal clock, often called as internal clock. And this internal clock is often
Trial
under the
version.
control of the control unit, and control unit does just everything with respect to the
Trial
internal
version.
clock frequency that is being connected. So typically something like 1 to 8 megahertz of frequency
Trial
is
version.
used in any PLCs for the functioning of the PLC.
Trial
This
version.
frequency determines the operational speed of a PLC. Yes, if a frequency rises, then
Trial
the
version.
speed at which the different job are being done is being increased. So frequency
Trial version.
increases, then the speed at which a job is executed also increases. As I already mentioned,
Trial
whether it is
version.
a data transfer from and to external memory,
Trial
or
version.
whether it is transfer of the control signal, just everything happens with respect to frequency
Trial
side.
version.
So obviously, if the frequency available is higher, then the time duration is lower
Trial
and the
version.
time required for completion of a job reduces. So that is why often
Trial
this,
version.
the frequency determines the speed at which PLC works, and it
Trial
provides the
version.
timing and synchronization for all the elements in the system. Now, as I already mentioned,
Trial
control unit
version.
always does every job, each and every job with respect to the clock.
Trial version.
So clock with higher frequency means lower time duration, and whether it is synchronization
Trial
or
version.
timing or operation, just everything happens with respect to this particular frequency, which is called internal clock.
Trial version.
Then bus system. Buses are very essential because they are the
Trial
basic
version.
transportation systems that exist inside any
Trial
CPU
version.
or even outside the CPU, right? Because they are required in order to transfer the
Trial version.
data, in order to transfer the address, in order to communicate between different components.
Trial
Hence,
version.
every component that is present inside a CPU or inside a PLC must be interconnected
Trial
with each other.
version.
And most of the time, these are copper wires, which are often called as buses.
Trial
So a
version.
bus system carries information and data to and from the CPU, memory, and input
Trial
output.
version.
So whether it is different components of CPU or different components of memory
Trial
system
version.
or input output devices, every one of them must be interconnected if they have
Trial
to
version.
communicate with each other. And of course, without communication between these components, the given task
Trial
cannot be
version.
completed. That is why it is very essential to interface all these components
Trial
with each
version.
other, and that interfacing or that connection between different aspects or different
Trial
components
version.
is always done using buses. And of course, in the microprocessor, we have
Trial
learned that
version.
there are wide varieties of buses that are connected, something like data buses, something and address buses,
Trial
control
version.
buses, so on and so forth. Every one of them basic job is the same,
Trial
to
version.
transfer the or to transport the data or information from one place to other place to which
Trial version.
these devices are connected. There are several memory elements
Trial
like
version.
system ROM, that is read-only memory, and this gives permanent storage for operating
version.
system and fixed data. So in any system, an operating system is very much essential,
Trial
and
version.
that operation system must be booted whenever the system starts, and this operation
Trial
system
version.
will not change now and then. That is why it is always safer and better to place
Trial
that
version.
operating system inside a permanent storage device. And ROM, read-only
Trial
memory,
version.
is one such device. It is a non-volatile device. It is a permanent storage. And
Trial
operating
version.
system always is fitted into the system ROM. And one more thing
Trial
is
version.
we often call it as post-operation, power on self-test, post-operation.
Trial
That
version.
post-operation always remains constant. Every time whenever we switch on a CPU or PLC,
Trial version.
that set of job needed to be mandatorily be done, which may include the
Trial
testing
version.
of input devices, testing of output devices, testing of memory devices, then loading the operating system,
Trial
so on and
version.
so forth. All of these normally are called as post-operation, POST, power on self-test.
Trial
and
version.
the program required to execute the post operation is always kept
Trial
in
version.
permanent storage, and system ROM is one such device.
Trial
Then second one
version.
is RAM, random access memory. This is a temporary memory, is a volatile memory. As soon as
Trial
power is
version.
switched on, the RAM could be loaded, but as soon as the power
Trial
is switched
version.
off, whatever data that is stored in a RAM, it is all gone. That is why it is called
Trial
a
version.
temporary memory or a volatile memory. So RAM
Trial
for the
version.
user's program, yes, user's program keep on changing. So today we may be using the PLC for one
Trial
function.
version.
Tomorrow we may have to change the function for which this PLC is used. Under those circumstances,
Trial version.
this data, this program must be stored in a place
Trial
which has
version.
facility to refresh it, change it. So that is why it is often kept in a temporary
Trial
memory
version.
or temporary buffer stores, as it is termed in a PLC. So
Trial
RAM for the
version.
user program and temporary buffer stores for the input and output channels. So input output
Trial
channels, whatever
version.
things that are needed, it is always kept in a temporary memory called a RAM or random access.
Trial version.
So next we will
Trial
pass on
version.
to input-output interfaces. The processor receives information from the external devices and
Trial
communicates
version.
information to the external devices. Most of the time these are all called as
Trial
peripheral
version.
devices, or called peripheral because they are connected to the periphery of
Trial version.
any PLC or central processing unit. That is why they are called as peripheral devices. And
Trial
these
version.
peripheral devices are obviously needed to be connected to the central processing unit. So that is why
Trial
the
version.
so-called interface is needed. And that interface is needed in order to supply input to the
Trial version.
CPU or to take away the processed data or
Trial
output
version.
from the CPU to the other devices. So that is why input devices and output
Trial
devices
version.
are very much essential. So basic job of input devices is to supply the input to the central processing unit.
Trial
And
version.
basic job of output devices is to supply the output of processing to the
Trial
user
version.
or to the human value. Right? So all these things needed to be interfaced with the CPU.
Trial version.
So the processor, hence the processor receives the data from the input devices, which are external
Trial
devices,
version.
and it also gives the processed input or output back to the
Trial version.
external devices. So that is very much essential in any
Trial version.
microprocessor based or microcontroller based systems. The input and output units provide the interface
Trial
between the
version.
system and the outside world. If we have to talk, if a user has to talk to the computer, it
Trial
has to
version.
be done through the input devices. And if a user has to take the processed input
Trial
back,
version.
there must be an output device. So it is possible for humanware to communicate with
Trial
hardware
version.
and software only through these devices, which are called interface devices, input
Trial
devices
version.
like a keyboard, mouse, so on and so forth. Output devices like visual display unit, printers, plotters,
Trial
etc.
version.
Right. A PLC may also needed to be connected to such input devices so that user can
Trial
pass on the
version.
data into it, or it may have to connect to the output device as well, so that it will like a
Trial version.
visual display unit or a LED display, a very small LED display, so that it could
Trial
also be
version.
connected to a small plotter as well, printer or plotter, so that the output of it could be printed.
Trial version.
So all these things are possible if the interface is built. So interface is very essential in order to
Trial version.
communicate, in order for communication to happen between hardware and the humanware.
Trial version.
The input-output interfaces provide isolation and signal conditioning
Trial
functions,
version.
isolation and signal conditioning function, so that sensors and actuators can often be directly
Trial
connected to
version.
them without the need of other circuitry. Now we know that
Trial version.
PLC is nothing but a CPU. It is a processing device. It is a microcontroller. For processing,
Trial version.
obviously, inputs are required. Otherwise, what to process? Now, when it comes to what to
Trial
process,
version.
the input are needed to be supplied to a processor in order to process it. Where does the input come from?
Trial
It
version.
comes from input devices. One of the best input device used in control systems are sensors.
Trial version.
Sensors convert the physical quantity into electrical signals often and supplies that one for processing. So processor receives the electrical signals supplied by the
Trial version.
sensors. Then it produces the output, or it processes the data and produces the
Trial
output.
version.
That particular output, what to do with that output? That output is essential for doing or for
Trial
controlling
version.
the system. Question is how to control the system. To control the system, actuators are needed.
Trial
So
version.
actuators control the system. Sensors send the input to the system.
Trial
So
version.
controlling is done based on the input sent by the sensors. That is why sensors are essential
Trial
as
version.
input devices. Actuators are also important as actuating devices or output
Trial
devices.
version.
So these devices could be interfaced with PLCs directly
Trial version.
if a proper interface is needed. So if proper interface is provided, then external other circuits
Trial
are
version.
not needed, right? So normally input-output ports are being provided on PLCs to which
Trial
sensors
version.
and actuators could be connected. Inputs might be from limit
Trial
switches.
version.
So not just needed that it is always from sensors, limit switch could also
Trial
send
version.
inputs like when we talk about cylinder
Trial
sequencing.
version.
Cylinder sequencing. Cylinder sequencing is totally controlled by limit switches. So if a
Trial
cylinder
version.
is extracting, so extracting the process is complete. How to say that one? Normally
Trial
a limit
version.
switch is been placed over there. When the piston totally extends, then
Trial
at
version.
the end of the extension, it starts a limit switch. It switches the limit switch on. That
Trial
limit
version.
switch sends a signal which could be used for next process that must be happening in the sequence.
Trial version.
Right? So limit switch can send the input to the central processing unit
Trial version.
to tell that look, the said process is either complete or said process has started or something like that.
Trial
So
version.
normally inputs are received by the PLCs through these limit switches as
Trial
well,
version.
which are activated when some event occurs. Yes, when some of, like in the case the cylinder
Trial
sequencing,
version.
cylinder is totally extended, totally open, or piston is totally
Trial version.
extended. So that could be identified if we have a limit switch kept in the sensor.
Trial
It could
version.
also happen through other sensors such as temperature sensors, flow sensors, etc. All
Trial
these
version.
sensors or limit switches will send the input to the programmable logical circuit.
Trial version.
The outputs might be to monitor starter coil
Trial
and
version.
motor starter coil or solenoid valves, etc. So as I already mentioned, once the signal is
Trial
processed,
version.
then the PLC will decide how to control the system. How to control the system? Either by
Trial version.
activating a hydraulic system, pneumatic system, or activating a motor starter
Trial
coil,
version.
or maybe other solenoid valves, etc., etc. Right? That is how it could be done.
Trial
So
version.
most of the time, hydraulic and pneumatic systems are connected to these electrical actuating systems like solenoid
Trial
valves or
version.
motors, right? So that signal is basically coming as a output from
Trial
the
version.
programmable logical controllers. So next one,
Trial
input
version.
channels. So in the figure, what we are seeing is an input channel. So it is the basic form of input
Trial version.
channel that we see over here. So wherein there is input that is coming,
Trial
there
version.
is input that is coming, so to the PLC, and opto-coupler is one very important
Trial
part
version.
that couples this input to the CPU, and it is many
Trial
times
version.
acting like a protection device, as it has other protection devices as well.
Trial version.
So this particular figure shows us the basic form of input channel.
Trial version.
The digital signal that is generally compatible with the microprocessor in PLC
Trial
5
version.
volt DC. So basically these things are working at 5 volt DC. In the first lecture we talked
Trial
about
version.
Arduino controller, and you must be knowing that even Arduino controller works with
Trial
5
version.
volt DC. Most of the inputs and outputs are at 5 volts. But later, if it is needed to
Trial
be
version.
enhanced, it could be enhanced as well. However, signal conditioning
Trial
is
version.
the input channel. Signal conditioning in the input channel with isolation enables
Trial
a
version.
wide range of input signals to be supplied to it. Now, this isolation is very
Trial
important part
version.
when it comes to PLC. Like, you know that we can connect the motors to the
Trial
PLC,
version.
and motors often work with the higher voltage. Maybe something like 220 volt AC motor,
Trial version.
something like 110 volt DC motor. So all these high voltage devices are
Trial
often
version.
connected to PLCs at the output level. At the input level, of course, it may be something like 5
Trial
volt
version.
DC. And PLCs often work at say 5 volt DC. And
Trial
when we
version.
connect a very high voltage to a PLC, there is a danger that that high voltage may
Trial
nearly
version.
burn the PLCs. That is why proper isolation between these high voltage devices
Trial
like
version.
motors and solenoid coils must be done from the low voltage working PLCs.
Trial version.
So that isolation is often done by a opto-coupler.
Trial version.
So the term used is opto-coupler. Coupler is used for coupling the signals
Trial version.
from CPU to output devices as well. Output or input
Trial version.
devices based on the kind of input devices that are being connected to any CPU.
Trial version.
So with the larger PLC, it is possible to have
Trial
inputs
version.
like 5 volt, 24 volt, 110 volt, 240 volts, so on
Trial
and
version.
so forth. But note that CPUs often work with 5 volt DC. So that is why coupling
Trial
this
version.
one requires an isolation as well, whether it is input or output.
Trial
A
version.
small PLC is likely to have just one form of input, something like 24 volt.
Trial version.
Arduino has just one form of input, that is 5 volt DC, right? So smaller PLCs
Trial
could
version.
also be designed to give a one single voltage, that is 24 volts, which means that this PLC could be used
Trial
only
version.
with the 24 volt input or output and no other inputs and outputs.
Trial
Whereas larger
version.
pieces could be devised with the proper opto-coupler and isolation systems for varying values
Trial
of
version.
voltages. The next, coming to output unit.
Trial
Now,
version.
input to the output unit will be a digital
Trial
signal
version.
from the digital signal from PLCs, which is often 5 volts. So
Trial
the
version.
input that is coming to a output device is always coming from a PLC, because
Trial
output
version.
devices are connected to the output of a PLC. So that is why input to output devices is
Trial
coming
version.
from PLC. And that, as I already mentioned, they may be, the PLCs are working at 5 volts
Trial
DC.
version.
So that 5 volt will be coming to output devices. Outputs of output unit
Trial
are
version.
specified as being a relay type. So output of this output unit could be
Trial
of
version.
relay type, transistor type or triad type. Note that relay types are electromechanical devices,
Trial
whereas
version.
transistor type and triad type are electronic devices. So relay type has its own
Trial
advantages
version.
and disadvantages, so do transistor and triad types. With the relay type, the
Trial
signal
version.
from the PLC output is used internally to operate
Trial
in
version.
relay. Now, signal is coming from CPU. That signal is used only as a signal
Trial
for
version.
the relay, just to make it switch on or switch
Trial
off.
version.
Right, but actual output that is going to actuator system is not the one that is coming
Trial
from
version.
PLCs. So PLC only sends the signal for a relay,
Trial version.
and that signal will either switch on the relay or switch off the relay. That's all. Then input
Trial
of
version.
the relay, maybe a higher voltage, is coming in, and it goes to the output, and to the
Trial
output
version.
a actuator system may be connected. So there are three things present in a relay. First one is
Trial
the signal
version.
that is coming from PLC. Second one is the input that may be coming from AC mains, and
Trial
third one
version.
is the output that normally goes to any actuator system, something like a solenoid
Trial
coil or a
version.
motor that is working with 220 volts, right, depending on the design that we have done.
Trial
So
version.
they are able to switch currents of the order of a few ampere in an external circuit.
Trial version.
So external circuit totally is controlled by something else, right? But
Trial version.
PLC normally sends a signal that helps in turning
Trial
this
version.
relay on or off. The relay isolates the PLC from
Trial
the external
version.
circuit and can be used for both AC and DC switching. So if we supply
Trial version.
AC to relay, relay will give AC output. If we supply DC to relay,
Trial version.
relay will give DC output. So this input and output are different from the signal that is being sent
Trial
by the
version.
PLC. So signal sent by the PLC is only doing one job, either to switch on the
Trial
relay
version.
or switch off the relay. If relay is switched on, whatever we have connected
Trial
to
version.
input, that goes to the output. If relay is switched off by PLC, whatever input that we have
Trial
supplied
version.
is seized from the output. So that is how a relay-based system works. Relays are, however,
Trial version.
relatively slow to operate because they are electromechanical devices. Then they have all connected
Trial version.
problems associated with any other electromechanical devices. The
Trial
transistor
version.
type of output uses transistor to switch current through the external circuit. So
Trial
in place
version.
of relay, it is possible to have transistors, or it is also possible to have triac also. And we already
Trial
know
version.
that transistors and triacs are nothing but switches, including a diode. Diode also acts like
Trial
a switch.
version.
Transistor also acts like a switch. One of the function of transistor is switch. So relay
Trial
is also
version.
nothing but a switch. So relay, if we replace it with the proper transistor or a triac,
Trial version.
then the job which otherwise done by relay will be done by transistor. And a transistor has no moving parts,
Trial version.
unlike a relays. So that is why transistors are much faster when compared to relay.
Trial version.
And wear, tear, heat raise, all those things are very less in a transistor because there are no moving
Trial
parts
version.
in transistors.
Trial
Opto-isolators
version.
are used with the transistor switches to provide isolation. So opto-isolators, that's what I said.
Trial version.
So higher voltage is connected to output or maybe the input as well to a PLC. Then they
Trial
are properly
version.
must be isolated from a PLC, so that we can prevent the PLC from
Trial
such
version.
high voltages entering in and destroying the PLC. So opto-isolators are often
Trial
used for
version.
such purpose. So isolation, opto-isolator, controlling transistor
Trial
switches.
version.
So transistor switches along with opto isolators will provide isolation between the external
Trial version.
circuits and the PLC. The transistor output is only for DC switching. Transistor output
Trial
is
version.
only used for DC switching. So even if you use a transistor as switches,
Trial version.
so it merely receives some input from PLC and does a switching job. If the circuit
Trial
is
version.
on, it turns it off. If circuit is off, it turns it on. That's all. That's all what a transistor
Trial
does.
version.
It normally does is DC switching. Triac outputs can be used to control external loads which are connected
Trial
to
version.
AC power supply. So most of the time transistor work with the DC, whereas triac work with the AC.
Trial
as well.
version.
They give output even for AC because two transistors connected reverse will give a
Trial
triac.
version.
Right? So that is why they work with the positive half cycle as well as a negative half cycle. Whereas
Trial
transistor
version.
work with only one of the cycle, either positive or a negative. Right? So that is why triacs work with the
Trial version.
AC. They give AC output, whereas the transistor give DC output.
Trial version.
So last part of today's session, that is opto-isolators.
Trial
Opto-isolators are
version.
used to provide isolation, as I already mentioned. We can have outputs from
Trial version.
the output channels, which might be a 24 volt or 100 milliamps switching signal.
Trial version.
So the outputs from output channel comes in at this particular rating, and
Trial
a
version.
DC voltage of 110 volt, that is also possible with 1 amp, or
Trial
240
version.
volt at 1 ampere AC, that is also possible, or 240 volt 2
Trial
amps
version.
AC from a triac output channel, that is also possible. With the small
Trial
PLC,
version.
all output might be of one type, that is 240 volt AC at 1.
Trial version.
Right? So with modular PLCs, however, a range of outputs can be accommodated by selection
Trial
of
version.
proper modules in it. The next one, we will see something about
Trial version.
sourcing and syncing. Right? The term sourcing and syncing are used to describe the way in which
Trial version.
DC devices are connected to PLC. How exactly DC devices we connect to the PLC.
Trial version.
That is what tells us whether it is a sourcing that is happening or syncing it is happening.
Trial version.
Now in this particular figure, figure A is for
Trial
sourcing.
version.
So here note that with sourcing we use the conventional current flow direction. If you take conventional
Trial version.
current flow, that is current is moving from positive to negative of the battery, that is conventional current. So
Trial version.
direction from positive to negative, and input device received the current from the input module. Now you see that here
Trial
we have
version.
input module in the figure and a input device is connected. Similarly here we have a
Trial
input
version.
module and output load is connected. Now just see how exactly things are connected. Now note
Trial
that this
version.
input device is actually receiving the current from input module. Similarly, output
Trial version.
load is receiving the current from input module. Right? So if that is
Trial
the
version.
that is the case, receiving the current both by input device and output device, then it is
Trial
called
version.
sourcing. Whereas other two figures C and D tells us something about
Trial
syncing.
version.
So what is happening in syncing? See, input module we have here, input device is
Trial
connected over
version.
here. Similarly, output device connected to input module. Right? Now here,
Trial version.
current is given by the input device to the input module.
Trial
Similarly,
version.
current is given by the output load to the input module. If that is taking place, it is called a sync.
Trial version.
So in the sourcing, devices receive the current from the module,
Trial
whereas
version.
in syncing, devices supply the current to the module. That is the basic difference between syncing
Trial
and
version.
sourcing. With syncing, an input device supplies the current. If the
Trial
current
version.
flows to the output module from the output load, then the output module is referred to as a sink.
Trial version.
Right? So receiving is sourcing, delivering
Trial
is
version.
a syncing by any input device or output load. So that is all
Trial
we
version.
have in this particular session. Thank you very much for going through this
Trial
session.
version.
Next lecture we will see few more topics on mechatronics. Thank you.
Trial version.